For number 1, you needed to translate it into an expression. 1 less than twice a number would be 2 times some variable minus 1. Questions on that first one? The second one you are evaluating, so you're putting x and y's values into this expression and simplifying. So 3 times negative 1 squared minus 3 squared, make them both whatever that would be squared. And then 3 minus 9 is negative 6. Questions on that one? For number 3, you needed to solve this equation. So as you start solving this, you distribute and then combine your like terms. If you notice that you have the same coefficient, the 7, but different constants, the negative 6 and the 30, you could stop there and say this will give you no solution. Or you could continue to solve it. So here if I subtract 7x on both sides, I get negative 6 equals 30, but they don't equal, so that would be no solution. Questions on that one? For number 4, we need to find just the domain of this function. So remember, your domain is your x values. You're looking furthest left to furthest right. So furthest left, we start at negative 1. Furthest right, it keeps going all the way towards positive infinity. So either of these notations would be fine. X is greater than or equal to negative 1 or negative 1 to infinity, where negative 1 has a square bracket because it would be included. And then for number 5, you needed to solve this for y. Subtract 3x on both sides, rearrange it, and divide everything by negative 2 so that y equals 3 over 2x minus 4. Questions on that? Before we start our notes today, I need to talk to you guys about something, so make sure everyone is paying attention. Take one of your AirPods out, or if whatever is in your ear, take one out. Make sure you can hear. Jake, tap her. Take one of those out. Make sure you can hear. How many of you have already in your English class heard something about a STAR assessment? Yes, same thing. For those of you who have not heard that conversation, it's coming. So the county decided that they're going to see where you are in your knowledge in math and English. So we're going to take that test on Friday. It is a computer adaptive test, so some of the questions you may not know because it starts to get progressively harder as you answer more questions correctly. As you answer questions incorrectly, it will go back to the level at which you know.
Answers get easier, you're doing worse.
Yes. So there will be some that you can definitely answer. There'll be some that you may not be able to answer, and that's okay. You do need your computer for that, so make sure you bring your laptop if you don't do that on a daily basis on Friday. I will send out a reminder Thursday night or afternoon or evening to make sure you bring that. If you forget or don't get those or don't check that, I'll send you to the library to grab one.
What happens if you're not here on Friday?
Technically, you should be making this up. If you come see me before or after school, that would be when you would make it up. Alex?
Is the test like multiple choices?
I think there are some multiple choice. There might be some fill in the blank. I'm not 100%. Some of the example questions I've seen were mostly multiple choice, but I think some of them weren't also. Garrett?
Is it like just a class period?
Yes. Yes.
Guys, just do what you can. Don't feel badly. I mean, if it's stuff we haven't covered in a while, or you haven't seen in a while, and like, don't just, it's just to kind of see where you are. So don't get hung up on remembering or not remembering, just do what you can.
I mean, I also think like some people are starting.
Josh, hold on 1 second.
Is this going on like a final grade or is this like just one-off sort of deal?
It's data that I will have that somehow the county will get, and then you'll be taking this test again towards the end of the year to see like your growth from now till then.
Okay.
Any other questions about this?
Why is this test being made?
That's not a me thing. Someone way higher up decided that we were going to do this.
This like
Again, what I'm trying to say is don't stress, you know what I mean? Don't feel anxious or, you know, like you're not gonna get a lollipop or something, you know.
Just try your best.
Try your best, relax.
is this for all grade levels?
9 through 12, yes.
And will our parents be seeing this?
Seeing the scores,
Yeah.
I have literally no idea the answer to that question. I could ask and get back to you.
Please and thank you.
I'm going to say probably not, but I don't know.
Because I have
For
a
certain.
cousin and she's a grade below me and she's really smart and my parents wanted to compare me to her. Don't want that to happen.
Yeah, I have no idea the answer to that question.
You look at it like it's another step to preventing Alzheimer's. Get your brain moving at age 16, 17, you know, it's preventative.
I think that's what it is.
Okay. Any other questions about the STAR assessment? The main things, bring your laptop on Friday. We're going to take it in class. There are some instances, like if you don't finish, I could give you more time, but you would have to come before or after school. If you're not here, you would have to come before or after school to take it. But it doesn't count towards anything except some data for the county. Yeah, scary.
Is it like a set number of questions or like?
It's 35 questions.
So they told us it's supposed to be 34, but it could be 35 or 36. In case anyone was wondering, I forgot about this. Each question, you have 3 minutes per question, unless you get extended time.
And there's time on top of that?
So each question is timed, but not the test itself. It's weird.
No,
So-
3 minutes is crazy. No, God, 3 minutes is crazy.
So you have 3 minutes to answer the question. I think at 15 seconds, a timer will pop up to let you know you need to choose an answer. And then if you don't choose an answer and it times out, you miss that question.
What? That is crazy.
Okay. Some of them you won't need 3 minutes. Some of them you will. And that's okay if you miss some.
When the county decided to do this, they're wicked.
Last week. They decided last week that we were going to do this.
Oh, they're wicked.
All right. Any other last minute questions on that? All right.
I'm
Josh.
Will this decide like what type of like, let's say class like for math and reading we take next year? Or like English? I mean?
I doubt it. It's really to see how much knowledge you have, how much knowledge you gain between now and the end of the year. Maybe they start making this a regular thing starting next year. I have no idea.
I heard that it's because because of COVID and how like it
Yes.
changed.
Yes. Because it's really just to see where you are, how much you know.
Oh, so it's really just pointless.
Yeah.
That's
Your words, not mine.
the story. Now I know how you feel about it.
Okay. Alright. Everyone should have these notes somewhere in the papers on their desk. Our new unit is on factoring. So some of you will have seen this before, depending on where you were 2 years ago before COVID happened. So if you're a junior, you probably didn't see factoring at all. If you're a senior, you should have seen factoring, but you may have not. Last year was the thing to say you didn't see it. So this may be new to some of you. This may feel new to some of you, but we're going to talk about each of the different types of factoring and things like that. Right, to get our brains moving, let's quickly do these 3 problems. What would I need to do here? Multiply. So I'm distributing. Here, when I'm multiplying, if I have an A and I'm multiplying it to another A, I'm going to make that A squared, not 2A. And then A times 7 would give me 7. Same thing for the next one, except now I have an M and an M squared. When I multiply those together, what do you think I would get?
Multiply M squared.
M squared and M. It'd be M cubed. So then the next one would be negative 12 M to the second power. We're taking both M's and we're basically combining their exponents, adding their exponents together. And then negative 2 times negative 1 would be positive 2. Then if we were to take this last one and distribute it, you have 4 x to what power?
Can you say that question one more time, please?
When I multiply what's outside here to x squared, what would my new exponent for x be?
No. 4 with the 5. Oh,
5.
so I was right?
I was right.
We said it first. We just said it lower. And then the y would just be 1y. And then if you multiply this to the second part, we'd have negative 8x to the third with how many y's? Or what is the exponent of y?
2.
2. Okay. Now, we know how to distribute. The exponent thing might be a little new. But distributing is not really what we're focusing on here. We're we're basically undoing distributing, which is called factoring. So in this part right here, this would be separating a polynomial back into a product.
Wait, Miss Dawn, I have a question. So it's 4x5y minus 8x3.
Y squared.
Where'd you get the 8x3?
4 times negative 2 gives us negative 8. And then already had x to the third. This one didn't have any x's to combine with.
Got it.
It was already right here.
Okay.
We basically multiplied it by 1. Sorry about it. Over here, because there were no x's. So when we factor, we're basically undistributing, but saying that is weird, so we're factoring. So let's say I had something like this, where it already distributed, like 4a squared plus 8a. I just made something up. Our goal is to get it back into this factored form, what it looks like before we multiply. I'm going to write what that is, and then we'll explain how we got that. When we go back to the factored form, we're dividing out anything that the terms have in common. So in this case, if I look at both of these, let me fill this in, and then I'll talk through the steps as I do this. Are called, that should be an M, not N. So as I'm looking through this, I'm looking for what number could I divide out of both of these things. What number did you say? 8. I could divide an 8, but this one would give me a fraction. So I want to try to avoid getting fractions. So what other numbers could I divide out of both of them? I heard you say something, but I didn't hear what you said. 2 would work, but we want the highest number we can divide out of both of them.
4.
So 4. So if I were to, I'm going to do this off to the side. If I were to divide both of these by 4, what would be left is something that can't be factored anymore. But these both also have an A value. So since they both have an A, that's something else I could divide out of both. So instead of just dividing out 4, we're going to take the smallest number of A's I can take out of all of them. How many A's can I take out of both of these?
How many A's?
A's.
1.
Just 1. Can't take 2 because this one doesn't have 2. So I can take an A out of both of these.
Sort of as a paper Band-Aid.
Yeah. Big, small. Big, small. Big, small. That's actually 10 bit.
Sorry about that. No, he can wait. He can wait.
Okay. So we're finding the biggest number we can divide out of both and the smallest number of variables we can take out of both. And once we find whatever that is, that would be our GCF, our greatest common factor. We can take that, and we're going to put it on the outside of our parentheses. And then, because we're dividing both of these terms by that GCF, we need to see what's left. So if I were to divide this by 4A, what's left?
A.
This
1A.
A, which is why we have A in here. And then if I were to divide this by 4A, what would I have?
Just 1. Oh, 2.
Just
Whoa.
2.
That's kind of off there. You heard that? Out of here.
Which is why we have that on the inside. Now, that was me explaining how that came about. We'll do more so that you get more practice. But do we have questions on that so far? Once you get the hang of it, it's not that bad.
They try to show what If you had 2 people, this person has red eyes.
Some of these together. So starting with number 1, we have 3x plus 12. What is the highest number we can divide out of both? Can I divide 4 out of 3?
Oh, sorry.
Will I say it out loud? 3. So that's going to be my GCF. If you want to write your GCF out on the side, just so you know that's what it is. It would be double the work if you do that, but if it helps you understand that's what it is, that's fine. So you're going to take that and you're going to write it outside of parentheses. Then we're going to divide both of these by 3. And when we divide by 3, whatever is left would be on the inside. So 3x divided by 3 would give us what? X. And then 12 divided by 3 would give us 4. If we wanted to, we could distribute this back out and see, do we get our original? So I'm going to do that really fast. If I multiply this back out, I have 3x plus 12, so we know that works. When we factor, our goal is to get prime factors. Prime meaning it can't be factored anymore, I can't divide out anything else. So x plus 4, there's nothing else I can divide out of there except for 1. And so it's prime. Josh.
So basically the GCF is the number that you're using to get it back to the original equation?
Yes, the number that you're dividing to get back to the original equation. Yes. Other questions on 1? Sometimes the number that you see, the smallest number you see, will be the GCF. Sometimes that's not the case. So look at number 3. What do you think our GCF would be? What is something we can take out of both 4? And sometimes you may not be sure. So if you aren't sure, what I would do somewhere off to the side, list all your factors of 8 and 36. So 8, we have 1 and 8, 2 and 4. Of 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. And of all of your factors, you would look for the highest you could divide out of both. Like these both share a 2, but that's not the highest because they both share a 4. And then for sure, you would know that 4 is the GCF. Yes, that's a lot of work. But if you don't know your factors, you may need to do that.
I mean, that sounds light. Easy. Give me the test right now in the store.
You thought I could try something?
Right.
Just a math.
I wrote this, but I didn't finish. So we know 4 is the highest number we can divide out of both. Can we take out any variables?
Yes. No. The N.
We can take an n out of both?
No.
No. They both don't have m, or they both don't have n, so we can't take out any variables. So be careful with that. So if I'm dividing both of these by 4, what's left on the inside? Willow?
The M and the N.
Yes. Willow?
2m plus mod n.
So you weren't wrong, Josh, but you just missed the numbers. So now when I look at this factor, I can't take anything else out of this inside. The inside is prime, so this is my answer. Do we have any questions so far, Garrett?
No.
Okay.
Greatest common factor, it's what they share in common. I didn't give you a great example with the 3i, 2i. It has to be multiplication and division. It's nothing to do with addition and subtraction. It's multiplication and division. Numbers that multiply together equal another number. In other words, it's not going to be 7 plus 1 equals 8, or 35 plus 1 equals 30. It's multiply. Two numbers or more multiply together to equal a particular number. Those are factors. So think in terms of multiplication, division, not in terms of subtraction and addition.
So if you build in the equation to answer
Kind of. We're trying to get it back into its factored form, like what it would be before we would have distributed. Okay. Let's move on to the back. Let's do number 5. What is a number I could divide out of both?
For which one?
5. 3. So if I were to divide 3 out of both. Now, once you get into the habit of this, you don't have to put this part here. But if that helps you see what you're doing, continue to do that. What would be left on the inside if we took out 3? Well, is there anything else we can take out of the inside? No. So that is fine. That would be our answer. Let's do 6. What is a number I can take out of both of these? 4. Now, let's say we forgot about 4, and I know these are both even, so I could divide by 2. So we're going to end up with 4, but let's say we forgot about it, because sometimes that happens. I'm going to go off 2, and we'll see what happens. Can we take any common variables out? Willow? Why? So if I were to divide 2y by everything, what would be left? 2y minus 12. Yeah, so now my inside, I can still take a 2 out. So if you get something like this where you can still divide something out, that means you didn't choose the highest GCF first. But that's okay, as long as you do this. So I can divide 2 out of this again. So I'm going to bring that out to my front, or out to the front. I would divide each of these by 2, leaving me with just y minus 6. And then I would combine these 2 to get 4. So you would get the same thing either way. It's just if you don't take out the greatest first, you're going to end up with more steps. Do we have any questions on that one? Oops. Right. We'll do 7 and then we'll jump to some other ones. For 7, what would our GCF be? So, just 3? Could we take out a variable too? Which one? D, because they both have a D. If we were to take 3D out of both of these, or divide both of these by 3D, what would we get?
7. Minus 1.
Minus 1.
I feel like once you get the hang of this, it's pretty easy.
Sure.
What do you think, Ms. Stark?
I agree. Yes. Yeah.
Okay, so going here. I gotta play a game for this, right? Just for you. You ready? I got 4 and 8. Ready? Is the greatest common factor 2 or 4?
2.
It
was a joke answer.
It's 4 because it's always the highest number.
Next time you get another try.
Ms. Stark, I think you should take care of that.
No.
That answer.
Hey, number 9.
No, Frank?
What would our GCF be for 9? Willow.
15.
Just 15? Can we take out any variables? 15 is definitely the highest number. Can we take out any variables?
Yeah.
So a squared and b, 1a, 1b. How many of both? One of each. I can only take 1a out of both because this one doesn't have 2 and there's only 1b. So our GCF, and I stopped writing this, would be 15ab.
Okay.
If we divide everything by 15ab, what's left? or just A. Not minus 1.
Right.
Minus 2. But you were close. It's alright. Okay. For number 13, we're going to skip some. Is there anything I can divide out of 13?
Wait, can you scroll up to the 7 real quick? Just like up and down. Alright, got it.
What would my GCF be for 13?
Right.
Willow? That one would be prime. Here your GCF would be 1. I could divide them both by 1. But it wouldn't change anything. So this would be prime. So if you cannot factor out anything or divide out anything except 1, your answer would just be prime. Let's do 14. If you need to, list out your factors off to the side. What are some factors of 18? 1 and 18. 2 and 9. 3 and 6. And that's it. What about 48? 1 and 48. 2 and 24. I don't know if it's divisible by 3, but I feel like it is. We need to check what that is. Alex? 4 and 12. 4 and 12. 3 and 16. Any others? So our GCF number would be what? 6. And then can we take out any variables?
We're doing which one right now?
14.
14? You can take out none.
1A, 1B, and 1C?
Oh, so it would be 3, like, ABC would be like 3 times, right? So like, it'd be like ABC, ABC, ABC.
Could you take out 2 C's?
You can take out 2 C's. Say that one more time.
Hold on, I'm not understanding how it's. So it's like, it'd be like, if I were to write ABC 3 times, right?
Okay. Unless this has parentheses, this entire thing is not to the third.
Oh, only the C. Okay.
Only the C. Okay. So yes, 2 C's, 1 B, 1 A.
See, that's where it got me. I didn't.
I just want to make sure that I clarified that. Okay. When we divide that, what would be left?
Do your word search. It would be 6, 1A.
Not 6.
Oh no, it would be 3.
3 A.
And then no B's, right?
Right.
And then minus
No C's. Minus
8, 1C.
Yes.
Oh my god, I really do this stuff. I'm telling you, you need a test right now.
This is lesson 1 of 5.
5 lessons?
Yeah.
Oh my. Oh, play something good.
Now let's do 15. It's the same thing, but now it has 3 terms. So we have to look at all of them and find the GCF for all of them. What could we divide out of all 3?
Put it 15, right?
15, yes. x.
You can take out,
Say one part, and then I'll have Alex say another.
you can take 1x.
Yes, you can take one x.
You can divide them all by 2.
You divide them all by 2. Anything else? And we can also take out a y. So if we divide them each now by 2xy, what would be left?
X, 9, y, plus 2.
Plus 2. It looks weird,
No.
but that would be our answer. There's nothing else we can take out of that inside. What's another one? We'll do a couple more and then I'll let you try some. Let's do 16.
Is it Spanish?
Now, because there are more numbers, the factor tree may really help you really see, okay, what would the highest of all of these be? So I'm going to do that really quickly over here. So for 9, we have
I'm saying you put this on the card.
1 and 9, and 3 and 3. For 18, I'm going to disregard that it's negative right now. I'm just looking at the number itself. We have 1 and 18, 2 and 9, 3 and 6. So right now it's looking like 3, but we need to make sure. Then for 24, we have 1 and 24, 2 and 12, 3 and 8, 4 and 6. So of these two, it would be 6, but this one doesn't have a 6, so that's out. They do all have a 3. So that would be our GCF number. Can we take out any variables? Yes, and how many? Y squared. If I divide everything by y squared, sorry, this is the wrong one. That's here.
Oh, I didn't see.
Oh,
And be the brick you are.
so not y. 16 variables, not y,
Bro, I used to
R.
do this all the work.
and not an s because this one doesn't have
This is
an
the
s.
house at.
No, I'm just talking about the
Literally.
Okay, so if we divide everything by 3r squared, what's left? Would be 3. Think about subtracting when you have an exponent. Josh.
Sorry, I'm so sorry.
So r to the 6. And then the last one. So even though I could take something out of 3 and 6, I can't take something out of 8 also. Even though I could take something out of 6 and 8, I can't take something out of 3 also. And then the same thing with the variables. So that would be prime inside, even though it doesn't look like it. It looks like I should take more out, but I can't. I was going to say, take it out and put it back in, and that would work. Alright, we're going to do one more of these, and then I'm going to show you how you could do this kind of on Desmos to use for practice purposes. Let's do 24. what number could I divide out of each of these? 3. The lowest number. Remember, that's not always the case, but in this one it is. So 3. How many of each variable, if any, can I take out? 1 of each. 2 of each. 2 out of B and C. I'm just making sure that I understand what you're saying. Yes, that's what you're saying. We can definitely take 2 B's out, yes. Can we take 2 C's out of everything? No. So we can take 1 C out. How many A's? This one. Because this one only has 1. So 1A, B squared, 1C. And let's divide. When we divide, what's left? And if you need to, when it gets to more variables, go back to dividing it, actually writing it and then dividing it. Do that so it helps you see what's left. What would we have here? A squared. And that's it for that one. For the next one, we also have a number here.
Minus 3.
Minus 3, 1A, 1B, and 1C. I'm running out of space. And then for the last one, what would be left when we divide that part? 5B squared, C squared. So all of this is supposed to be in one line. I just ran out of space. So far, do we have any questions about GCF? Finding it, dividing it out, seeing what's left? Okay, so I'm going to show you a trick that you can use on Desmos while you're practicing. Granted, you will not be using this on the test, so I wouldn't rely on this, but definitely use it if you cannot think of the factors. So on Desmos, there is an option to find GCF. You have to go into, let me see if I remember this, functions. This just updated, so it looks weird. In number theory, GCD is what you're looking for, the greatest common divisor. When we find a greatest common factor, we're dividing, so those are the same. So GCD. And then what you would do is take all the numbers, just the numbers, not the variables, from your problem. So let's say we go back to 24. And I put in 3, you have to put commas in between all of these. So 3, 9, and 15. It will tell you what the greatest common factor or divisor is number-wise of all of them. You would still need to figure out your GCF for the variable part, if there are any. But this will help you while you're practicing. But again, don't rely on that. Use it as like a worst case scenario if you can't figure out the factors. Questions on this? So you have a bunch of different examples on the page we were just on, as well as the last practice page. I want you to go through as many as possible for the remainder of class and see what you can do, need help with, understand, or don't understand. Anyone have questions on what we're doing for the remainder of class? You guys have this time to work. And let us know if you need our help.